So this is the reproduction and inheritance test, model answers and commentary. And we're on the last question now, which is question 8. And Oestrus cycle and synchronized sheep. And we've got a 5 marker to start with about the Oestrus cycle in a female mammal. So even though it talks about sheep later on, you know about the Oestrus cycle in humans and the hormones involved. And it's a straightforward question. Describe the part played by FSH and LH. So really we should be getting 5 out of 5 for this, even if you get a bit confused with the graphs and so on later on. So what do we know about FSH and LH? Well, let's just put in a starter. Hopefully we'll snag a mark here, say where they're produced. So they're produced in the anterior pituitary. So produced in the anterior pituitary. So that might get a mark. And let's talk about our 2 hormones now. So let's talk about FSH. Make sure that you are really clear which one you're talking about. You can't just make vague comments that might apply to both or one. You need to be clear. So let's talk about FSH. And as the name suggests, follicle stimulating hormone. The main thing you're going to say is it causes the follicle to develop. So causes the follicle to develop. Where does this act on? So this is a hormone, so it would be wise to talk about the target organ. So the target organ is the ovary. And what's going on then? Well, this is then going to lead to the release of estrogen, remember your FOLP, and eventually cause ovulation. So as the follicle matures, estrogen is released, and this is going to cause ovulation. And we're sort of putting 1 mark on every line here and get yourself organised. Let's talk about LH now, luteinizing hormone. So this is the one where the surge in the hormone causes the follicle to rupture, and which is ovulation. So in a nutshell, this causes, so the surge of this causes ovulation, which is the rupturing of the follicle. So the female oocyte is going to be released from the ovary and from the follicle. And we could say here what the follicle is going to do. So the remains of the follicle will then release progesterone. Remember, FOLP, so the LP of FOLP. And so really, 5 marks here. Should really, absolutely, definitely be getting, causes the follicle to develop, works on the ovary, leads to the release of estrogen, a mention about ovulation, and then progesterone. So, just from your notes, part B, we're now moving on to synchronized sheep. So we're synchronizing the estrus cycle, and then we're doing that so that the lambs are born at the same time. And more of that later. And in this experiment, they're giving them some progesterone and then stopping the treatment, and then the sheep all have their estrus cycles synchronized, so they'll all then be exactly the same point on the cycle, hopefully. Why does progesterone prevent estrus in sheep? So this is taking your knowledge of the estrus cycle and just applying it to this new situation, that AO2. And so what does progesterone do? Better say that. So progesterone inhibits the release of LH. That's one of the jobs that you know about progesterone. And we're going to use our keywords here. So how does it do that? And that is by negative feedback. So that'll actually get you the 2 marks, but why are they doing that? So no LH surge, so we're going to get no ovulation. So that's what's actually been prevented. And after we stop the progesterone treatment, sheep will then come into estrus. Well, it's really just the other side of the coin from the previous answer. So now, if we are stopping the progesterone treatment, we're not going to inhibit the release of LH anymore, and so we're going to get this ovulation. So that's the answer. So the inhibition of LH is removed, and so there is a surge in LH and ovulation. So they're all in cycle now and ovulating at about the same time. And here's the results of the experiment. And here we have, so we've got the first lamb being born. That might have just been kind of one on a day, we don't know. But then each day they just counted how many lambs are born. And there appears to be a clear kind of cycle there. We've got a lot of lambs being born there, then some being born there, then a spattering in between. Whereas our control sheep, there's no clear cyclic pattern there. This is possibly just the pattern you might expect at this time of year. Using the information in the graph, we need to do this. Suggest an advantage to the farmer of synchronizing estrus cycles in sheep. So why do we want them all born at the same time? You need to come up with a sensible suggestion there. Well, maybe the farmer has equipment or labourers on the farm or help on the farm, or something set up where it's much more efficient if all the lambs are born at the same time. You could make preparations and so on. Less fatalities because the vet might be present in the concentrated period. That sort of idea. So let's put that down. So lambs born in a short space of time. So, for example, can supervise lambing more efficiently and easier to make preparations, less fatalities, and all sorts of answers you could say here. Yeah. But those will do for the moment. And also you might not know much about sheep, but quite often just one ram might actually fertilise many sheep. So you sometimes see lambs in the field, rams in the field, sometimes with a fitting on them with a pen, so that they can, when they mate with the ewes, then they make a mark on their back so they can keep track. But these rams, might be on loan. We don't know. It might cost a lot to have a ram there, or they might not want a ram in the field when lambing's on and that sort of thing. So it's a good idea to have the ram in the field for a short period of time, and of course when all the ewes are in oestrus, you can in time with each other, then it's efficient use of the ram as well. Excuse me. So, more success with things like introducing the ram, or indeed if you are artificially inseminating these ewes, then if they're more likely to be all in oestrus at the same time, you're going to be more successful with that. So also more success with artificial insemination, for example. So there's lots of different reasons there. You just need some sensible suggestions. Estimate the length of an oestrus cycle in sheep. Explain how you arrived at your answer. Well, we're going to go for these cycles. So, how you arrived at your answer? So, look at the peaks in number of sheep giving birth. So we've got sort of that sort of shape there, and we've kind of got this sort of shape there. And we're going to read this off there. So we've maybe got 4 or 5 there. So we'll call that 4. Call that 20. Each one of these bars is 1, so 21, 2, 3, maybe 23. So 4, 23. So according to this, mine would be 19 days. The peaks at days 4 and 23. I'm currently looking at a mark scheme that says 15 days, peaks at day 5 and 20. Well, I'm going for 4 and 23. But as long as you explain how you arrived at your answer and the numbers add up, then that's a sensible way to get 2 marks there. Then just this last couple of marks, explain how the control group of sheep should have been treated. And you know about controls, we need to kind of remove the active ingredient or the thing that we're investigating, but everything else should be the same as much as possible. So we have the same treatment. What was the active ingredient in our treatment? So that was the progesterone. So however they've introduced this, you know, same treatment, e.g. you actually use kind of sponges and coils and things like that, but you might have a description from your imagination about what goes on. Same treatment, but the important thing is, but no progesterone. That's the important thing. And why are they doing this? So maybe if the way that they've introduced the progesterone might actually have the effect rather than progesterone itself. So we're just kind of explaining that, you know, so that the treatment itself has no effect. And I would be, it's not in the marks again I've got here, but I'll be tempted to put, you know, all other factors to be kept the same. And I would even give an example, e.g. same field and that sort of thing. Same age of the sheep and that sort of thing there. Okay, 15 marks. Quite a difficult one, but hopefully you got the ones that you should have got.